Data Analytics with AI series, and I hope everyone is excited and ready for another insightful learning session. Myself, Tanmita Sarkar, I am the host for today's masterclass, and I'm very delighted to welcome Mr. Karthik Huda again with us today to take through this masterclass, right? As his profile has already been shared with you all, so without taking much time, let's get straight into today's learning, right? So, Mr. Karthik, over to you, and the session is all yours. Thank you, and everyone, let's get started.
Thank you very much, Tanmita. Hello, everyone. Welcome to the third masterclass. And I really hope you are all ready. So, without further ado, let's get to the main task. All right, let's begin. So, should we have any Q&A before we, go into our main task for today? Q&A specifically about what we did in previous two classes. If you have any questions or queries about the previous two classes, you put them in the chats right now. If you don't have any, let's take 2 to 3 minutes. If you don't have any queries, then we'll go ahead with it. Or else I don't see a lot of messages in the chat box. All right. So I believe last two classes have gone fantastic for you since you do not have any queries. All right. Let's go ahead. So in the previous two master classes, we started with basic cleaning exploration of data, where we got a very raw, very messy data set and we cleaned it into something much more meaningful, much more understandable, something much more worthy of analyzing. We'll also learn about various types of data analytics that people often do that are available, that can be done and should be learned. And then the second master class, we performed something called the EDA, exploratory data analysis, where we use Google Colab and Python to basically understand what the data is, what the data was trying to tell us, what are the different elements of data. We learn about different variables, how they were behaving, how they were interacting with each other. In the end, we also came up with outcomes, insights, hypotheses, and recommendations. So after that, now we move on to a very special type of data analytics called, and we also learned about this, that is called predictive analytics. And today we are going to use artificial intelligence to develop a customer risk prediction model, or we can also call it, we will use uh, predictive analytics through a practical customer risk prediction challenge. So, very simple for you to understand. If you are worried about the word churn, so today we are going to build a customer churn model, customer churn prediction model, a model that will predict. So, churn basically means, so if a customer, we are not likely to retain a customer, or a customer who we believe has already left us. So that particular customer we call as a churned customer. Somebody, if somebody has not, uh, made a purchase in a very long time, or very inconsistent. So the basic definition of churn is not set. We always, the analyst or the business, they always define what the basic definition of churn is. It could be customer who does not make a purchase, customer who is not regular, customer who does not buy consistent products. You can have any definition of churn, but basically it helps us understand our customer behavior. And based on that understanding of customer behavior, we are going to build a prediction model that will also help us understand the behavior of our future customers. All right, now let's get started. So we, something we already talked about. We started with descriptive analytics. We moved on to diagnostic analytics, and today we are covering predictive analytics. So we already know what happened. We know why it has happened. Today we are going to figure out what might happen, and very soon we'll find out what should we do about it. All right. So prediction. is not about knowing the future. Although prediction is a word very uh, related to knowing the future. People often talk about that, this was predicted, that was predicted, it turned out to be true. But it is not about predicting the future. It is about using historical patterns to estimate the likelihood of an outcome. So we use historical patterns to estimate what particular outcome is most likely to happen. For example, in this case, whether customer will end up churning or not, or what percentage of customers will end up churning, what are the chances of them churning or not churning. So not necessarily predicting the future, but using historical patterns to estimate the likelihood of an outcome. So now a clear definition of what is customer churn. Churn in this case, so remember I told you in the beginning, the definition of churn is always subjective from analyst to analyst and from business to business. The example that we are taking a look at today, here a customer becomes inactive according to the business's definition. So here, as we go ahead, do not worry about that. As we go ahead, we'll set our own definition of churn. And after setting our own definition, we'll build a prediction model based on that particular definition. So here in this particular case, if we had a customer who had, a good purchase history, was consistently buying, and suddenly there was long inactivity, like for a period of month or 2 months or 3 months, the customer did not buy anything. We will consider that as a period of long inactivity and define them as churn. Now, because they are churned or not churned, based on that, we'll calculate the risk. So if a large segment of our customers end up being the churn customers or likely to churn customers, that will set up as high risk. If it is medium, then medium risk. If the number is very low, then low risk. And as you can see, low risk means very recent and very frequent purchases. Medium risk, that the purchase frequency used to be high, it is slowing down. And high risk is, of course, very long inactivity and order values falling. Then how prediction works. So even if you go to the senseless predictions that people try to make, that what's going to happen tomorrow, where a stock might go, where something might go, to all the way up to prediction using data analytic, prediction that is set, that is rooted in sensible data. So all those happen via historical data. We take up historical data, we find out what the features of those data is, we build a model around it, that model predicts, and from that prediction we assess the risk probability. So we already have our historical data that we cleaned in our first masterclass. We identified its features in our second masterclass, and today we are going to build the model. So an example of a good prediction model would be if there is low purchase frequency, long time the last purchase, and the order value is falling. If this all combined, that is like a mega event that has happened. That if all three main variables of ours combined, then the churn risk goes to a maximum. All right. Now here comes features of a prediction model. So features for prediction models also varies from model to model. When you develop your own model, maybe it has different database, different types of functions that you want from it, different types of prediction that you want from it. In this particular scenario, the three main features of our prediction model will be recency, frequency, and monetary value. So recency, how recently did the customer purchase? Frequency, how often did the customer purchase? And monetary value, how big the revenue is. So why these three are important? Because it is possible that customer does not buy that often, but whenever the customer buys, the customer spends a large amount. So that also works. Instead of 10 orders of 100 rupees, if we have an order of 1000 rupees, they are both of equal value. And of course, that also works with recency. If a customer spends 10 rupees every month, at the end of the year, customer would have spent 120 rupees. But if a customer spent 120 rupees in January, then we might think customer is very old, but we look at monetary value and we find out that no, the risk is not that big. Now, additional features that we can add, what the average order value is, different categories that the customer has purchased, and the regional information. Because location can have some context. Because if we're selling something that does not, sell to a particular location or not very usable in a particular location. For example, selling raincoat in a desert. Sounds very stupid, but if we were selling raincoat, we would not expect a lot of sale in dry areas or in those areas where rain frequency is not very high. That does not mean people will not buy raincoats there. Of course, for that limited rain period, they will end up buying. And same goes for the opposite, high sales or high value in high rain frequency areas. Now, moving on. So, how do we test whether the model that we have made, if that model is any good? First of all, of course, it should be accurate. So, based on the kind of data we have, and based on the kind of output we want, it's possible, although very rare, that your model is 100% accurate. It's possible it is 90% accurate. It's possible it is less than that. And it really depends on how accurate you want your model to be to give it a green flag. If your data is horrible, very inconsistent and very unclean data, it's possible accuracy might be as low as 10%. So based on that, that model is not any good, the data is not any good. We need to either recollect our data so that data is better, or maybe perform a better cleaning of our data, better organizing of our data. Then precision, of course, when it predicts high risk or low risk or medium risk or any kind of risk, how often it is right. And then comes the recall value. So how many actually high risk, low risk, medium risk customer does your model is able to recognize? So these are the three main elements for this particular model. Please remember, as I'm continuously repeating it, different models that we make have different features, different evaluation criteria. Now the confusion matrix could be actual versus predicted, where if the model predicts that something is very high risk, but it was actually low risk, then it would be termed as false alarm. If something was predicting high risk and it is actually high risk, then it was correct. Predicted low risk, actually high risk, then it missed the mark. Predicted low risk and actually low risk, then it is also correct. Now, here we come to which model would you choose? As I've been mentioning since the beginning, that every business, every different business scenario, every different business function requires different kind of models. So let's say in this particular scenario, this is not our old data. Now imagine this is our new data. So the business scenario is that a new company that can only contact 500 customers. So in that particular scenario, currently in our database, we have over 2000 orders. So let's say company can only contact 500 customers. Would you rather have a model that catches more risky customers or one that is correct more often when it flags? So now see here your choice comes. So the previous evaluation criteria that we had, accuracy, precision, or recall. Now you have to make a choice. If you have to basically have higher frequency, you want to catch more customers, but you want to risk on the accuracy, or you want to catch less customers but have higher precision and higher accuracy. Now of course there can be different permutation and combination, but I hope you understand what I'm trying to say here. Now then after that comes the judgment. Now whatever prediction model that you make, or whatever your model is performing, now please understand, the performance of your model is not directly your business decision. So the way your model performs, based on that, you will also mix in your business context. Like what kind of business, for example, the same example that we took of, selling raincoats in a dry area. Let's say if you had a business of selling raincoats, if you made a model based on raw data, it will, basically give us an outcome that the customers in maybe Jaipur, I'm assuming Jaipur is a dry area, the customers in Jaipur are, very high risk customers. They will churn. They are not a regular customer. But then if you put in a business context, the Jaipur is a dry area. So the final outcome or the final performance of a model will is not the accurate business decision. It will tell you that in Jaipur, you have to add that context that it is a dry area, or something like, Meghalaya is a very high frequency rain area. And after you combine the both, you get a useful business decision. So that is why, along with your model, your business context is also important. And then we'll go on to turning our predictions into risk scores. So we already talked about it. So we can maybe set a number. If the risk probability is, let's say, more than 70 or 65, anything, it can be as high as 90, 95. It is totally up to you. You term that as high risk, then maybe something 40 to 60 as medium, and anything below 40 as low risk. And based on that, you apply different strategies. For example, you currently see on your screen, let's say the customer C102. Turns out customer C102 has a high risk. So maybe you try to understand the customer, what the customer buys, or what the customer used to buy frequently but has stopped buying, or the frequency is not high. So maybe provide, better discounts on that particular product, or, have more types of product in that particular product category. The business decision, of course, comes later. But we are basically told what customer are high risk, medium risk, and low risk. Then association versus causation. So model will identify patterns without proving why they happen. Because as we understood the four types of analytics, uh, descriptive, then diagnostic, predictive, and prescriptive. So in this particular case, a model will only identify patterns based on the raw data that we have. It does not mean that it cannot prove. It can also prove, but we are currently working on the data that will only identify patterns. And then we come in the business context comes in, the different scenarios comes in, and then we also prove along with it why something has happened. All right. Again, I have a question for you guys. Let me go to the chat box, and you can, in the meantime, you can go ahead with the read the question. So, what statement do you guys think is the safest to present to management? Low purchase frequency causes churn. Low purchase frequency is associated with high predicted churn risk. I see very few answers today, but I see a lot of them are B. B, some say C and D. So I believe today I have asked the right questions as there's a mix of responses. But yes, most of you are correct. B is the right answer. So what we basically mean, what statement is safest to present to manager or somebody senior, is the model find patterns, not proof of cause, associated with accurately reflects what the model can support, causes and proves why, overclaim what a predictive model can tell us. So I hope this is a very self-explanatory statement that we, with our analysis, with our predictive model, we will not be presenting causes. We will not be, saying things like that this proves this proves that. We will just present what our findings are and what it is associated with. So we know low purchase frequency is often associated with higher predicted churn risk. Why it is happening, our model is not telling us, or our not also not proving what is the cause behind it. Okay. All right. Now let's move on to the practical element. I hope you are all ready. So as always, I'll provide you a workbook that you guys will utilize to work along. if you guys are on your laptop. Otherwise, you can save this workbook and later on you can utilize this to work in your own time. All right. Here goes the link. So the link is in your chat box right now. Oh, I just realized. I'm sorry, guys. My camera was off. I just realized that, but no problem. I hope it is on now. All right. Let's go ahead. I hope you all have the link and you have the workbook downloaded. So now let's get back to our practical part. So I hope you all remember this. So guys who are new here, who did not attend the previous classes. So this is the database that we started with. Not necessarily this. This is the raw database that we started with. And by the end of first masterclass, we had actually cleaned our data and this is where we had reached. Now we will go back to our beloved Google Colab. Wrong Google spelling. So again, something for people who are new. So this is what we were working in the second master. So in the second master class, we used AI to generate Python codes for us, and we utilize those Python codes, discover the story hidden behind our data. The next thing that we are going to do is we can basically continue working in this particular sheet, but just to keep it safe as the notebook for our second masterclass, we'll simply create a copy for this. So if you are on your own, yeah, it is your choice. If you want to continue working in this, you can, but I will make a copy for this so that this stays safe and whatever changes we are making, they go and happen in a new sheet. All right. Not a new sheet, sorry, new notebook. All right. So here it is. Now comes the time to open our workbook. Okay, now let me share my screen with you guys. All right, here is the screen. So I hope everybody remembers this is where we were in our previous masterclass. We had used Python to basically, analyze our data, clean our data, understand our data, discover the story behind it. Then we also used Python to create various visualizations. Then in the end, we had our outcomes, we had our insights, we had our hypothesis, and we had our recommendations. This is all that we had done. Now I hope everybody has the workbook. Let me just, if you have workbook, maybe you can show me a thumbs up and we can go ahead. Let me get my workbook as well so we can work together. So I have basically created a copy of this particular second masterclass notebook, which we are going to rename and start reworking with. So let me get my notebook. And where will I find my notebook? All right, I'll go to my drive. All right, here it is. I have found my workbook as well. And here is my workbook. Oh, I realized my screen wasn't shared. So here is my workbook, and I'm sure you all have the copy of the same. All right. So here is our older one. We will get rid of this. Not basically get rid, just close it. Please do not delete it. Delete it. So starting with, So we already know we have a clean data set with us that has these different variables, order ID, order date, customer ID. We are already aware of that. So please make sure you do not change the original data set. So open Google Colab. You will find the link in your workbook, and you can either create a new workbook, or where there basically you have to continuously import more and more of your data set. But not to worry. So I am going to keep this as the name for my new workbook. Sorry, not new workbook, new notebook, rather than a copy of the second notebook. And there we go. And now we'll start with creating our prediction model. So first and foremost, of course, we have to load our data, but our data is already loaded. Since we did not create a new worksheet, we did not basically create a new database. Our sorry, our data is already loaded. I hope you remember from this the first command that we used in our previous session, this particular one. We used our Google Sheet to load our data into Python. So our data is already loaded into Python. So people who are new, maybe we can show to them how our data can be loaded. You can basically go to Ask Gemini and provide your Google Sheet and specific group ID of your clean data sheet. And from there on, it will generate a Python code for you guys. And then you can basically load your data. All right, now let's go ahead with our prediction. So here is, so this is for all the new people. The first prompt that you see, that is for loading your data. But our data is already loaded. But just as an example, I'll copy this, go to Gemini over here, paste my prompt. Oh, did I put the link? Did I not put the link? I uploaded clean. So it has basically done it. I don't really see the, okay, so what it has done, it has basically created. So what I will do, it has created a CSV file of its own, but that is not what we want. So what I will do, copy my sheet link. This is my sheet link. And then, and this is my GID or group ID. So group ID is basically ID for with in your large spreadsheet that you have. If you see in your Excel sheet, there are various spreadsheet. GID is specifically ID for that particular sheet and not the entire thing. You see, if I change the sheets here, the GID for this is 0, GID for this is different, and then GID for all the sheets are different altogether. You will see as they change. But currently we want our second sheet, that is the clean data, and it will create this. We'll copy and basically create a new code snippet, bring it all the way down and put my code here. And then I'll click on the play button. So what it is currently doing, this particular Python code is loading our sheet into the pandas library. So it will take some time. Okay, I see a few raised hands. Is there any questions or query that you guys have? Okay, so we first, so right now it is asking us access to our sheet. So I'll provide that particular access. And that is it. Our access has been provided. And there it is. So basically, our data is loaded, data that was previously in our Excel sheet, as you can see here, our data with order ID, order date, customer ID, and so on. It is now loaded into pandas, or basically loaded into Python as pandas. So order ID, order date, this is same data that we had. Now it is loaded. So we'll see also different elements. It is also telling us what the data type is. There are 2000 rows and 10 columns. This is something that we've previously seen. So now moving on, we have checked our columns. Now my data set has these particular columns. I need to identify which columns correspond to customer ID, order date, revenue, order ID. Now, if you were using different database, different data set, this prompt is specifically for you. I am going to skip it right now. The reason it is for you guys, that it's possible that you are using a different data set, and there, instead of customer ID, there is a cust ID, or say CUST ID, or order date is order or underscore date. So just to match with it, you will utilize this prompt. I am going to skip this one right now. So now here, right now, we are going to begin our prediction part. So what we are going to do right now, if we go to our data set right here, so this particular data set is basically, if you see, it is mainly based around the orders. And why I'm saying it is based around orders, you see, it has basically listed down every single order that it has. Now, if we are going to find out, make a prediction around orders, then this might work as it is. But we are trying to make a prediction model based around customers. So we have to basically build a database around customers. So we don't really have customer name, mobile number, email ID, nothing unique. We only have customer IDs. So what we eventually want to make, that is, rather than a customer entry in multiple cells or multiple rows, we want that all of the data related to a single customer ends up in a single row, so that customers are basically not repeated. Just like all the order IDs here are unique, similarly, we want a separate database where all the customer IDs are unique, and everything related to that particular customer is stored in one particular row. So what we'll do for that? So a good example is this, that all that for customer one, all this, the customer one has placed 8 orders. So this is not accurate. This is just a sample. Customer two has placed 3 orders. Total revenue, the sum of the total revenue for one is 24,000, for two is 7,500. Average order value is 3,000, and then so on 2,500. So as I said, we want one customer per row. Now what we will do, we will ask Gemini to basically create a customer level database. So we want Gemini to basically create a code for us that will create our customer level database. So you see, although I've been repeatedly mentioning this in all the master classes, so please go through the prompts in a lot of detail. Please read them in detail, because there is no right or wrong prompt. There is only wrong or right output. So whenever a prompt works, try to understand why that prompt works. So you can put that particular mindset, that particular process of writing a prompt in your future prompts. And whenever a prompt does not work, try and understand why it does not work. And you utilize that knowledge of yours to avoid doing that in your future prompts. So to make our customer based data, so what we are doing at first, we are making a very small customer based data where it has customer ID, total order count, and total revenue. Nothing very complex right now. So I will copy this particular prompt, go to Gemini and paste it over here. Now see the step that we skipped. I hope you the step about matching uh, column to every single name that it had. So if maybe there is something wrong, it will tell me right now. but nothing as of right now. Again, I'll create a new code snippet, paste my code over here, and then run it. So there is issue. So it could not convert string. So you see what has happened. Original data that we had stored, we had basically stored it in a string format, basically rupee symbol and comma and all that. So what we will do, so this code has basically gone to waste. So what we will do, I will basically write a new prompt of my own, that in my database, the revenue and profit are stored as string. Convert all of them in the entire database to integer. This is an issue we faced previously as well. So going ahead with this, so it has basically given me the command that will do it. I'll copy this, create a new code cell, paste, and run it. Update it. So it has basically updated, and you can see the output. It is only showing the first 5 rows, but the all the rupee symbol, comma symbol, all the unnecessary characters have been removed, and we have raw integer or raw numerical data. And now our previous code will work. So what I will do, go back in my chat and copy that code of mine, create a new code cell, paste it. And now, yes, as we expected, it has worked. So it has basically created a customer level data set. So as we remember, customer data set, it has, you can see, for each customer, there is one cell, then the order count and total revenue and average order value. So let me open the chat for you guys. Does anybody recognize the mistake here? I hope I want to see if you guys have been paying attention. I'll open the chat for you guys. So there is a mistake here, a mistake that we discovered in our first master, or based not discovered but created in our first master class. So I opened the chat box. So can anyone guess if you can see any mistake over here? Om Jadhav says data mismatch. Kishan says no mistakes. Okay. Om Jadhav, can you please be a bit more specific on what kind of data mismatch? Repeated data mismatch, date mismatch, blank customers. Yes, data type, converting data to values, decimal maybe. All right. So I don't think you guys remember exactly what we did in our previous. Now I have two or three correct answers. So basically, what we did in our first masterclass is that we cleaned our database. And when we were cleaning our database, what we did was whenever a customer ID was not available, whenever there were blank values, we replaced that with C triple zero. So, but here what has happened is that it has considered C triple zero as a unique customer. It might not really be a unique customer. We basically did that just to fill up the empty values. So what I'm going to do right now is I will rewrite this prompt just to say, so let me copy, where is the prompt? All right, here it is. I'll copy this prompt, and what I'm going to say, that please avoid using customer ID C triple zero. So I'll paste the prompt as it is, and just as, oh sorry, I pressed enter accidentally. I'll stop this. So let me paste this over here, and here I'll write in the end, where can I write? Maybe let's put it over here. I'll write do not, or I can just say exclude customer ID C triple zero. That is it. And we know we need to include the customer ID C triple zero because in the first masterclass, we ourselves put it there. It was not present. Okay, it says something went wrong. Maybe I something wrong with my internet connection. So we know that C triple zero is not the right way because C triple zero is not a real customer. It might be a real customer, but it is not exactly C triple zero because C triple zero is not a real customer ID. We put it just to replace the empty cells. So that is why right now we are going to basically remove that because keep in mind that is not real, that is just empty. The other part is real, the total revenue, average order value, and all that is real, but the ID is not real. Okay, so there seems to be some issue over here. Let me stop it. So you might also face issues like that, not to worry. Sometimes, Gemini and other, oh, it has worked. My bad, I'm sorry. I was just in the wrong place. So it has worked. So now what I'll do, so you can either delete this code snippet or you can choose to keep it. So if I just add a new code snippet, put it over here and run it. So this time, as you can see, it has avoided C triple zero and it has basically given me a customer level database for all of them. So now what I'm trying to do, just to be sure that my code has worked. So the basic idea, if my code has worked and we have created a customer level database, that means every customer ID should be unique. So for example, C triple zero one should not come again, C triple zero two should not come again. If customer IDs are reported, then our database is not created well because we want individual unique entries for every single customer ID. So just to check this, what I'll do, I'll write a small Python snippet. I'll just add a prompt that I want to check if all customer IDs are unique in this customer database. Okay, some spelling mistake, but not to worry. Gemini takes care of that. So let's copy this. So although this step is not mandatory, but we are just being safe. You know, adding a new code cell, and now we'll run it. Total unique customers 4 to 15. So yes, all customer IDs are unique, and there are a total of 415 customers. So you see, based on this, what we now understand that a total of 415 customers have made these 2000 orders, the 2000 original orders that we have. All right. Now from this customer database, we'll move on to making our prediction. So first part is done. We have made a customer loyal database. All right. Now the next part that we'll do, we basically made a very small database only with three main values. Now we'll add to it. We'll also add order average order value, the first purchase they had made, and the last purchase they had made. So, and this time, rather than displaying first 5 rows, I am displaying the first 10 rows. So what I'll do, copy it all the way up till here. And here also, what I will do, first paste it and simply add exclude customer ID C triple zero. And I will run with it. So basically, we had created a very small customer database. We are just expanding it right now. So why creating the small one initially, it is not mandatory, but it basically helps us understand that what we are doing it right. We first created a very small database, and from that we learned that we are able to create a unique database where a single customer's all data is merged and everything is unique. So we'll going ahead with this. This time I will just expand my database. So now you see, I have expanded my database. Previously we had customer ID. Now we have the order count, total revenue, average order value, first purchase, last purchase. And this is what we wanted. Total number of customers still unique 415, and these are the column names. So very simply we have expanded our database. So the next thing, here comes our features. I hope you guys remember it. We talked about this in the beginning. Now to the same customer database, we want to find out their recency, their frequency, and their monetary value. So this time, what we are going to do, we are going to ask Gemini to basically, first of all, we are going to tell it that this is my customer level database. It has these columns. And now I want to create RFM features. So RFM basically recency, frequency, and monetary value. So please provide beginner friendly pandas code to calculate recency, frequency, and monetary. All right. So very simple. I'll copy this thing and take it to my model over here, paste this and run it. So what have we learned? Basically, learned as a theory in the beginning. We are step by step covering all the steps that were initially there. So our code is done. Now it will create our features, adding a code snippet. So one more thing, although while we are running, so one more feature of Google Colab is that if you are, maybe too overwhelmed by all this code, just to, organize it better, what you can do, you can basically add text snippets as well. Nothing complex. If I just move it, so to basically identify everything properly, I can just name it as RFM. So I basically do not get lost. I just to make it bold. There it is. So we could have basically done it for all everything that we have done since the beginning, but just an idea. From this point on, we will do it. And why learning this is also important might not look as important right now, but in future when you're working in large teams, working in large firms, where there is a certain code of content, certain way of naming a file or naming a certain title, naming a certain section, following that is very important because while working in a team, the first person does not know what the thought process of 20th person is. So for the first person to be in aligned with the entire chain of 20 people, it's very important to follow a good naming convention, a good code of conduct. So that is why, although right now we can have anything, but just to have it as a practice. So the code that we used to find out our RFM. So what it has done, it has basically created our RFM data set, and you can see it has added recency, frequency, and monetary value. So the recency is 183, frequency is 1, and 65,000. To understand what these numbers mean, we simply try to understand what our prompt was. Number of days since the customer's most recent purchase. That is frequency. So what this means that the last time customer C001 made a purchase was 183 days ago. In the entire history, or at least the history of this particular data set, C001 has only made one purchase. The total monetary value for that is 65,000. And similarly, C002 made last purchase 117 days ago, has, 9 purchases, and monetary value is 2560. That is close to how much? 2,56,000. All right. So very easy to understand. Now we have created our features as well. We have got our recency, we have got our frequency, and we have got our monetary value. Now, how do we go ahead with prediction from this point on? We have ran our RFM code. Now we have to basically define customer churn. Remember, in the beginning, we talked about that in this particular scenario, what we are doing, we are basically setting this definition of our own. Now, remember, as I said, definition of churning changes person to person, business to business, and from analyst to analyst. But in this particular, if you guys are currently working on your own prediction model, try using a different definition, and you will be intrigued by the different results that you have. So, what I'm using a definition where a customer is considered churn if they're not made a purchase for 90 days or more. So basically, if recency is greater than or equal to 90, it is churned. Less than 90, not churned. All right. So we can change it based on our requirement as well. So what I will do, first of all, I will simply copy this particular prompt. Now, why I'm saying that we can also change it for our data. Let's first just check our churn value. So what we have done basically in this particular prompt is we are given a definition. A customer is considered churn if they have not made a purchase for 90 days or more, and create a new column. We will call it churn status. And if recency is basically greater than or equal to 90, it will mark it as 1, and 1 means churn, and 0 means not churn. So based on that, the code that it will create, we'll copy this from here. And as always, just to follow a good naming pattern, we will put this thing as churn status and make it bold, and then a new code snippet. And we will run it right now. So you see, there is the first 10 entries are all churn. We already knew that because we had seen the recency over here, and they were all greater than 90. Now, why I talked about churn, not churn, you will see that a total of 411 customers are churn and 4 are not. That means in our database, we have a very high number of churn customers. So what we will do, that we will basically change our definition of churning. So rather than 90 days, what we will do, we will simply change it to, let's make it 190 or maybe 180. Let's double it. And why I'm doing this, not that something is wrong with 90, but it changes person to person. And in this particular scenario, why I'm changing it, so that we do not have a very one-sided data. Because as you can see, out of 415, only 4 are not churned. That clearly shows that our data is quite, falling to a side. So we'll change our churn definition here. Because if we set our churn definition too extreme, then it will basically not give us a good business result. Because this just shows that our business is failing if we have 411 customers that are churned. So based on the business scenario, business context, what kind of data we have, we set our churn definition. And churn definition is not only about number of days recency. It can comprise of uh, multiple status. For example, we are making a churn statement based on only recency. So maybe we can have a statement that if a customer's recency is greater than 180, added on frequency less than 5, added on monetary value less than 1 lakh. So that makes quite a complex. Do not worry, we'll try that as well. So let's first try this with 180 days. So what we'll do, we'll change this. I'll just simply delete this, add a new code, and run it. So this time there are 275 not churn customers and only 140 churn customers. So again, the example that we took, so what we'll do, simply add to this 180 days more plus, or we can simply use the plus symbol, frequency is less than 5 plus, what was that? Mon- Monetary value is less than 100,000. All right. So we'll delete this rule for now because we have basically added more. So we can create new rules, but we'll not be spending a lot of time there. Now I'll do this. I'll copy all of it, copy it, paste it over here and run it. So now again, we'll find something new. So with the code that we have right now, again, what I'll do, I'll delete this one, paste and run. So now we have something different. So now not churned are 318 and churned are 97 because we have basically changed the. So what it has done right now, you see it is not combining all of it. So in terms of recency, 183, 1, and it is less than 1 lakh. So it was considered churned and so on. And we basically have something over here. So let's continue with this. Or it would be better if we just go on to our first one. Let's copy this. So trying to keep it simple over here, but you can use anyone that you like. So we'll go ahead with our older one with a very simple churn status of 180 days. Right? Now going over here. Wait, is there so recency 183 days? Yes, so we are correct here. All right. So we have basically provided churn status to our exist. Now remember, we have not done anything to predict right now. We are still analyzing our historical data. Historical means data of our past or what we have recorded till now. We are basically assigned churn status to all our customers. Now we will be setting up our model. So now what we do not want it to simply use the recency to predict churn status. When churn status was created directly from recency, that would give model the answer in advance. So what we do not want for the prediction model, we do not want it to simply copy the data that we have. We want it to analyze it and come up with what the prediction might be. So what we'll do, we will ask Gemini to check our data set. So again, what we'll do, I want to create a leakage safe customer churn prediction model. Before creating the model, inspect my data set structure and tell me whether my current churn status target is directly calculated from any of my prediction features. So what are my prediction features? Recency, frequency, monetary, and I'm also including average order value here. My target is churn status. So let's just see whether my model is simply copying the existing or whether we are doing something new. So again, this kind of serves as a check. All the analysis that we are performing, we have checks to perform in the middle. Now going ahead with this particular prompt. So while it loads, let's have another Q&A, a quick Q&A. So I open the group chat. So if you guys have any questions right now, resend the workbook. Tanmay, you can scroll up in the chat. You'll find the link to the workbook over there. All right, I don't see a lot of questions right now. Harsh says my screen has frozen. Uh, Tanmita, can you please let me know if my screen is frozen or if maybe I'm breaking up?
No, no. It is moving. I'm not facing the issue, Karthik. I think it is the network issue of the
All
student.
right. All right. Thank you, Tanvir. All right then. I don't see a lot of queries. So we will basically analyze our leakage. So basically there was no code over here. No code was needed. So AI has basically analyzed that yes, your current churn status target is directly calculated from your prediction features. Using recency in your feature set will cause 100% target leakage. Why this is leakage? Your target was generated using a rule if recency is greater than or equal to 180 and frequency less than 5 monetary and so on. Because recency along with frequency and monetary was used to explicitly define the churn status. The model will simply learn the exact rule rather than learning true predictive patterns. It will look like a perfect model with 100% accuracy, but it will fail completely in the real world. So basically, we are seen that only when it matches perfectly, it will work. But in the real world, when it everything does not align to our needs, it will not work. So how we are going to fix it? So use historical snapshot approach. So what I'll do that now I'm giving it this is the main line in this particular prompt, the first line. I want to create a leakage safe customer churn dataset from my e-commerce transaction data. Use the earlier historical period to calculate recency, frequency, monitoring, and average order value. Then use a later period to determine whether the customer churned. Our churn definition is no purchase for 90 days. Again, we'll change this over here and change it to 180 and so on. Now the main elements are inspect my available order date range, suggest a sensible historical cutoff date, future observation period based on only on days actually present in my dataset, explain the proposed periods before writing code, create customer level historical features, create the future customer churn status as the target, make sure information for future period is not used to calculate historical features. This is also very important. This is something that we learned that it is not basically leaking. So do not use feature information as a prediction feature. So whatever comes in from future, I hope you understand. You are understanding from this point. So for our future database as well, our future data will also have order ID, customer ID. Basically, our future data will also look very similar. So what we are telling our prediction model is do not use the recency from that data. The three features that we have, recency, frequency, monetary, and average order value, do not use it from future data, but rather use the past data or the historical data, and based on that make the prediction. All right. So that is what we are doing right now. So then we are basically saving our model from leakage. So I'll put this prompt over here. In the meantime, we can also see the other elements. So by 180 days, we have set for 6 months. And you can see now it is basically asking us to do something that we're already doing. We are creating our own leak safe window. So it has created this entire code for us. Again, I'll start with a text and maybe we can put it as leak safe first. On that is not a very good name. What can we have the name? Maybe we can have as okay. Let's have it as leakage safe customer churn. Leakage underscore safe customer churn. And then we'll add the code and run it. So a mistake over here. Let me fix it. So it has basically worked. So now this is our churn breakdown. 203 not churn, 191 did churn. And our final leakage safe data set of first 10 rows is this. All right. And if you have realized that our churn values have changed, they were different earlier and they're different now. And that is because we have altered our database to make it leak proof. And I hope you have already understood the meaning of leakage is that it is not using basically what we are trying to make a prediction model here. We are not trying to make a mathematical model. So mathematical model will say is what it is doing. It is simply taking the recency values, and if it is less than 180, it is giving it as 0. If it is more than that, it is giving it as 1. So that is very simple mathematical model. But what we are doing, we are trying to create a prediction model so that when the future orders come in, it is not using the same mathematical values of recency, frequency, monetary, and average value. Rather, it is using historical data. So we have basically now created that leakage safe data set. And these are the first 10 rows. And now we'll utilize this leakage safe data set to create our uh, prediction prediction model. So now what we're going to do, we are basically just again, this is again a check that we are putting in our new data set, the leakage safe data set that we have created. Now we're going to check that data set. All right, just to be sure, now we'll utilize this particular prompt to check that particular data set. So I'll put this over here, run it, and the outcome of this particular prompt will basically, so we had our previous all data set, we analyzed it, turned out it was not leakage safe. We have created a new data set that we have assumed that it is leakage safe, but we are going to check it again and make sure that it is completely leakage safe. So if any issues or any problems come in, so this basic output, so it has prediction features, the 4 prediction features, recency, frequency, monetary, and average order value. Target table is churn status, target leakage status, no obvious leakage present. So we have succeeded over here. There is no obvious leakage present. Now, what is this statement and importance? That there's still possibility we might come up with something in the future, might create leakage, but as of right now, our model is completely leakage proof. All right. And it is basically saying that we are not going to use customer ID or churn status as something as prediction features. We are going to use our prediction features, recency, frequency, monetary, and average value. And we already are aware of that. All right. So we have done our check. Our new database, that is our leakage safe set, that is good to go. There are no problems here. Here comes after a very long wait. Now we are going to build our prediction model. So to prepare the model, we have to use our features as we have already seen. Use recency, frequency, monetary, and average order value, and do not include customer ID or churn status as a feature. Any column created directly from the target or future information, do not include that. Only include these 4 values. So see, there is possibility that in future a new column might get added. Maybe with customer name, customer email, anything can get added. So we're telling, even in the future, even if new data is added, do not use that as well. Or if anything is added to the past data as well, do not use, only use these 4 values. And the 2 values that we obviously are not using is customer ID and churn status. So now we will ask Gemini to write the code for our model. Now here comes the task of creating our prediction model. So again, you see, I have a customer level e-commerce data set in Google Colab. My target variable is churn status. My prediction features are these. Use only these prediction features if they are valid and do not cause target leakage. I want to build a simple customer churn prediction model using logistic regression. Please generate complete beginner-friendly Google Colab code. Select the valid prediction features, select churn status as target, checks missing values, handle missing values, and so on. All right. I'll put this. All right. Before this, I think I should ask you this. So, how many of you know what logistic regression is? I just want to see. Maybe if you are not aware from programming or coding point of view, are you guys aware of what a logistic regression is? So we are basically using a logistic regression. I open the chat for you. So how about you tell me what your understanding of logistic regression is? I have always same complaint with Omjada. Omjada, can you please be a little more specific type of classification? Or like give me a definition. Yes, Isha, you are correct. It is an machine learning algorithm. True or false using sigmoid function, binary classification, unsupervised ML learning. It is classified myself. Okay, I still don't see good definitions. All right, I see one now. Logistic regression is a so Yash Kardam says logistic regression is a supervised machine learning algorithm used to predict the probability of a categorical outcome. Most commonly, a binary choice like yes or no. So yes, Yash Kardam, you are correct here. Okay, okay. Deepika, I would request that you do not spam the chat. All right. So basically, I will close the chat now. I would request Ayush to please take care of Deepika. Uh, all right. All right.
Uh,
So let's talk about logistic regression. Yes, Tanvira.
no, sorry. I just want to announce one thing that students, please, if you keep spamming the chat box, we have no other choice but to remove you. We don't want any interruption in between the masterclass. Thank you. Thank you,
Uh,
Karthik.
Tanvita, I would request please remove. Tanvita Ayush, I request please remove Deepika.
Yes, yes, yes.
Yeah. All right. Let's go ahead with logistic regression. So logistic regression is along with a mathematical function. It is basically a machine learning algorithm as well. And why machine learning algorithm? This algorithm is based mostly around probability, where it uses binary values like 1 or 0. And here we clearly know what the binary value is. That is our churn status. And using that, it makes prediction. All right. So I'll copy this code, paste it over here, and run it. So guys, if you have still any questions about logistic regression, then please let me know. Maybe we can, although we will not talk about logistic regression in detail in this session as we are short on time. Maybe next session or maybe at the end of session we can talk about logistical regression a bit more detail. But basically, the code that we wrote, Gemini wrote for our model that has completed functioning. So it has done. It says that there are no missing values, and for our feature, no missing values for our features, that is recency, frequency, monetary, and average order value. All data type for all of them is integer. Now total customers are 394 and training set 315 rows and 79 rows. So I hope you see from this particular place that from initially when we had 415 data 415 unique customer. Now we have remained only 394. So 21 are removed. So those 21 were basically those data points in our customer data set who are causing the leakage. And that is why we have chosen to remove them. So now our basic base of our model is now done. Our prediction model base is now set. So now we'll add to our base. Now what we'll do from all the features that we had already, I will we will add to those features. So in this, you will also see that I am not using a full prompt all at once. That is also a very good practice in the sense if you want to keep a good check using too much data, using too much code, or using a larger prompt at once. Not that it will not work. It will the output will be a bit bigger or maybe too big to analyze. That is why often using smaller prompts or half of a prompt or less than that often helps us basically understand. So now we will add on to what we have created, paste it and run it. So by the time it runs, let me open the chat one more time. All right, so this time I open the chat, but only for one purpose. Let me know if you want to learn in detail about logistic regression. Okay, so Mayuri says masterclass 2 open PDF. In... Okay, Mayuri, I would suggest that you upload the same PDF on your Google Drive and open it via Google Docs. So you see, I have done the same thing. This is not really doc file. This is actually I have uploaded the same database into Google Docs, and that is from where I'm working. All right, so I see a lot of yeses. Param, all the workbooks, all the important links, you'll find them in your resource document. Your resource document, you'll find it in your WhatsApp channel. All right. So a lot of people are asking for, work links that were shared in the previous class, shared in today's class. You'll find all the links. All right. So in short, we want logistic regression. So for this particular session, how about we go ahead with our model, and then towards the end, we can talk about logistic regression a bit more. All right. So based on our larger prompt, you see a much larger code is created. So we will add on. So our base of our prediction model is created, and we'll add to that base. Then removing this. So I first I'll simply name it as customer churn prediction model. All right, now to the code, and I'll run it. So this time our full is done. So basically how it has basically developed our performance matrix, basically developed our prediction model. So what you understand from this particular thing is we have already seen there are no missing values. Then the training set size is 315. So what is training set? Training set. So let me go take you back. So where were we? Okay, I accidentally deleted it. I'm sorry. So if you remember, we started with 415 unique customers. We removed how many? 15 plus 6, 29 of them to avoid leakage. And we were left with 394. Now, what we did with that 300, not we, what our code did with the 394, it divided it into two parts, not equal parts. So, what it did, it used the first 315 customers as our training data. So, what is training data? Any data based on which our model learns, our prediction model, our AI model, it learns. So if I have to give you a basic example how Gemini works, so we fed a lot of human information from various websites, various codes, all that data that was fed into Gemini, that was training data. And then now the prompts that we are providing, that is our test data. So in this particular database, the LLM or the large, all the large language database that is often used to create models like Gemini, ChatGPT, or Grok, Claude. That is our training data, and our prompt is our test data. So we have divided our 394 leakage safe data customers into 315 as training data and 79 as test data. We use the 315 data to train our AI model, our prediction model, and then we use this remaining 79 to test how good our model is. So imagine what it has done. It has basically treated 315 as historical data. So how it has worked, that it has completely separated them. It has treated 315 as data of the past, and it has treated 79 as something new has come up. Because if you go back to this data, our original data set, if I select all of this, put up a filter, and simply sort it by date, so I have sorted it by most recent to oldest. So from this, if I take the first 79 of them, so they were the most recent. Let's say I take them, I copy this, make a new file, and remove them from here. So our data will basically start from over here. And then what I'm doing, I'm telling my AI model that these 79 are new and only 315 are old. So what it has done, used 315 to train and used 79 to test that how good the training was, how good our model is. And upon testing, turns out accuracy is 70%. I believe that is very good accuracy. Of course, if you are not satisfied the result, you have to go ahead. Precision is 65, recall is 84. We already seen the definition of what of accuracy, precision, and recall, but that is what it is. All right. Now, what based on what these numbers have come up, that there is 70% accuracy, precision 65, recall 84. It has come on the basis on the confusion matrix. So let me take you back here. We saw this. So accuracy, how often our model was correct. Precision, when it predicts high risk, how often it is right. Recall, how many actual high risk customers did it find. All right. So this was the confusion matrix. And based on confusion matrix, the percentages were assigned. All right. So if you have, please let me know. I'll go to the chat. If there are any questions, any queries, any lack of understanding, I have opened the chat. Please let me know. Uh, if you clearly understood the confusion matrix and you have truly understood accuracy, precision, and recall. Okay, Kumar says recall, confusion matrix. All right, let me just tell you one more time about what confusion matrix is. All right, what I will do just for you to understand, I'll copy my entire database and let's create a new file. I'll paste everything. Maybe I can call it test. Then again, I'll select it, filter it, and sort it as oldest to newest. My figure doesn't seem to work. Okay, let it load. Okay, until then, we can go to the confusion matrix over here. So, from our confusion matrix, there are four main elements in our confusion matrix where it is false alarm, missed opportunities, correct with the correct prediction, and correct with the wrong prediction. Now, what the difference is that you predicted something correctly and it was actually correct. Then it is a correct prediction. You predicted something is wrong and it turned out to be wrong. Then it is not a wrong prediction, it is a correct prediction. Now imagine instead of high risk or low risk, let's say if we go to our sheet over here. Now I'll make a matrix over here. Now let's forget all the confusing elements of customer data, high risk, low risk. Let's say we wanted to basically test whether our result are correct. All right. So let's say very simple test. I ask you what is 45 plus 27. Let's say this was my question. Now, what I am telling you, I am not asking this to a student, I am asking for the answer. Now I am making a prediction model. Now what that prediction model will do is basically predict that when I ask students, will the answer be correct or not? So if the prediction model guesses, the answer will be correct. All right. And the answer the student provide, that is also correct. Then it falls into right prediction because what was predicted, that was the outcome. Now let's say the prediction model, it guesses that the students will provide wrong answer and the students actually provide wrong answer. So then again, this is correct prediction, this is the right prediction, this also falls into something right. So this we can term, maybe we can use colors to highlight them. Let highlight this as green. So we know if the answer was correct and it was predicted correct, green. If the answer was wrong, it was predicted wrong, again green. But if the answer was correct, but the AI model predicted that no, students will give wrong answers, that prediction is not right. And that is something where our model is basically lagging behind. So we'll make it mark in red. And let's say our prediction model says that students will answer wrong. It confidently says it they'll answer wrong, but actually they answer Correct. This is also in the gray area. Sorry. So I hope this helps you understand the prediction matrix. Now, how this prediction matrix goes into our data. For this data, let's say if we just take these 10 data, and let's say we forget our customer database is very large. So what we have done in our database, because we do not have any future data, we have to use current data itself to basically predict, make a model that will work for prediction. So what we have done within our current data, we have taken a few entries and basically told our model that this is not past data, this is actually future data. So it is not utilizing this to make the prediction. Now let's say for this thing it was 1 0 1 1 0 0, and I'll insert a blank column. And because this is already our present data, but we have told our AI model that this is past data, sorry, future data. So what it will do, it will make a model based on this. And based on this, it will just predict. So we know the real values. Real value is 101. But let's say we trained our database on this. And based on this, the prediction it made was 1, 1, and 0. So you see, this, let's do some highlighting. We'll highlight the actual values as maybe yellow, and the predicted values we'll highlight it as orange. All right. So it was a churn value. From this, we know that 1 means churn and 0 means not churn. So it was churn value, and our model also predicted it was churn value. So both correct. It will fall here. Green, green. So it was uh, original value. It was not churned, but our model predicted that it will churn. So it will fall here. Red. Then originally it says churn. Model predicted it will not churn. Again red. So that is how you see. This is how these 315 and 79 were divided. We basically know the outcome for these 79 customers because these 79 customers are present in our historical data. But we used their existing churn status, and then we also told our prediction model to use 315 data to set up prediction. And for these 79 customers, the accuracy was 70%, prediction was 65%, recall was 85%, and this was the confusion matrix. So you see true negatives, false positive, false negatives, true positive. We already seen it, but just to be specific, you will see these are true negative, or if we just go to our sheet, correct, correct are true negatives, wrong, wrong, sorry, correct, correct are true positives, wrong, wrong are true negatives, correct, wrong are true, sorry, false positives, and this is, sorry, this is false positive, this is false negatives. All right. So this is how it works. So it turns out from the 79 customers that we predicted for, it correctly predicted for 24 that they did not churn. And actually, in our original data, they did not churn. Then for 32 of them, it correctly predicted that they will churn, and they ended up churning. For 6 of them, it missed that they were churners, and it said that they are not churners. And for 17 of them, it said that they will churn, but they did not end up churning. All right. So that is why, based on this, we have 70% accuracy, 65% uh, precision, and 84% recall. Now, basically, our model is ready. Our base prediction model is ready. Now comes the question of how, basically, if we are not satisfied by what the result is, how basically we improve our model. So you see, after running, we see accuracy, precision, recall, we see the confusion matrix, customer prediction, churn probabilities. We have already seen this here. Everything is over here. Churn probability is also here. Now, based on this, we can either be satisfied by our first result, or we have to basically make our data much more, much more consistent, much more rigid. So our data is better. So now we have this option of basically understanding what our model result is. So basically asking Gemini what our result means. So no code will be generated here, but just to start with, I'll copy our outcome here. Copy this. Okay, close the sheet for now. I'll simply then go to our prompt and paste it over here. Now this is what I will use as a prompt. Now this is a step just to understand. We will not generate any code over here. This is just to understand our data. Not understand the data, understand our prediction model. Now it will give us what it thinks. Okay, something went wrong again. Let's wait for some time. Looks like my internet is a bit down. It is taking some time. All right, so it has given us an output. Okay, so it is again saying something went wrong. Let's go all the way to the bottom. I have reloaded it. All right, now let's understand. Okay, so it has not worked. Let me copy the prompt once again. And paste it over here and run it. Also, see, it is not necessary that if it is possible that your prompt might not run on the side, but it is not. You can wait for some time, try after later. You can also try with other AI tools as well. So here is a simple explanation of model's performance. So what does ease metric means in plain business language? If the accuracy is 70.89%, out of all the test customers, model correctly classified 70.89% of them as either churn or active. Business interpretation, nearly 71 out of every 100 customer status will be predicted correctly. So what you understand by this, that for your future customers, your AI model will correctly predict of all out of 100 customers. We can be sure it will correctly predict the outcome of 71 of them. It can also do more, but we can be sure it will correctly predict at least 71 of out of 100. Then again, for 65%, what it means, when your model sends an alert saying this customer is going to leave, it is right, it will be right for 65 out of the 100 customers. And again, for recall value of 84.21, when your model tells you that 34 out of every 100 churning customer before the left, missing only about 16% value. All right. Now, key question that are answered here: which metric matters more to identify as many genuinely at-risk customers? Recall matters the most. For this goal, high recall ensures that your safety net catches as many leaving customers as possible. If the cost of losing customer is high compared to the cost of retention effort, like an email or a small discount, you want to maximize recall. So fewer at-risk customers slip through unnoticed. So I hope you understand what you mean by recall. That how many customers will go through without notice. So since our prediction model is good, 84 out of 100 will not go unnoticed. 16 might slip out unnoticed. All right. And so on. Similarly, why high accuracy alone does not mean the model is useful. If 95% of your total customer base stays active, only 5% churn, a simple dumb model that predicts every single customer will stay could instantly achieve 95% accuracy. So I hope you remember when we got our results and I told you that I am very happy with 70% accuracy. That is what I meant there. Usually, when a model has very high accuracy, that actually means, so if accuracy goes beyond 90%, what I believe, if accuracy goes beyond 90%, your prediction model is most likely using skewed data because your accuracy cannot be that high. And same goes with other values as well. If values, often cross 90, or even when they start approaching 90, this is something to think that there is a lot of imbalance in your data. So as you know, as Gemini says here, a dumb model, where model is dumb because it is simply telling you that be relax about your business, do not worry anything, all your customers are good to go, all your customers are safe. And this is not really true in any business. So if a model is telling me 70% accuracy, then that means that is good. All right. Now, moving on, we have made our, what do we say, a confusion matrix as well. Now we'll add score. So remember in the beginning, we had created the probability. Based on this, now we will assign, you see, if it is below 40% low risk, 40 to 70 medium risk, and above it, high risk. All right, very easy to understand. We will just create a code that will basically assign high risk and low risk. All right. Okay, there seems to be something wrong. All right, until then, my Gemini comes back to its place. We'll look at what the future is. So once we run the risk code, that is the code here, it assigns the high, low, or medium risk. It will give us the result. And then we'll find the highest risk customers and separate our answer into was our observation. We'll move on to basically our business decisions. What is the observation? What is the insight? What is the recommendation based on it? And so on. We'll move on to that. And then basically understand, association versus causation, then what is directly related, what is indirectly related. And then, as we always do, why else are we, analyzing, why else are we predicting, to turn our predictions into a serious business action. And then we'll follow the same step to make our business action. So this will be our process. Let's get back. I hope my Gemini is in place now. Let's try to run that prompt. Okay, it has worked. So very quickly, since we are close to the end, first add. We'll just write it as risk value. Then paste this, run it. Is it has basically assigned the risk values, high risk, medium risk, and so on. And moving on, now we'll check who are the high risk customers. And for that, okay, first I'll put our 20 highest risk customers. Copy this and paste it into a prompt. So you see, again, this is not a code-based prompt. It will not generate a code for us, but rather it will give us observation and insight. Okay, little too big. So there is our table. Now we are basically asking Gemini or asking AI to provide us an observation and insight. We'll utilize this. See, also one more thing that can be done, although because various people use various ways, and also how Gemini works, we can simply copy this and see when we copy it, it will basically identify what you have copied on the screen. But right now, we'll just put the prompt with all our data and there you so the prompt this particular code that is not this particular prompt that is not generating any specific code can be put into any AI model that this particular AI, the Gemini here, is directly associated with our model. So again, our observation: low frequency, high recency, low to moderate monetary value, high monetary outliers, risk tier distribution, single purchase vulnerability, inactive signal, value based risk profile. So this is our input. This is basically telling us that there is a very low frequency. That is the top 20 highest risk customers. Basically, they are not, their frequency is very low. They are not buying a lot. And then their recency is very high. That means their last purchase was very long ago. Then their monetary value is low to moderate. Monetary value is not very high. The wherever the high monetary value is high, they are being termed as outliers. So what it is saying, why it is saying calling them outliers rather than calling them low risk, that although the monetary value is high, but recency and frequency still do not add up. So it is possible that they made a one big purchase once a long time ago, or maybe one or two big purchases, but since then their recency and frequency are not good, so they are still high or medium risk when it comes to churning. Then risk tier distribution, only two customers are high risk, rest of them are medium risk. Then it is possibly providing the what the insights are. That's single purchase vulnerability. A lot of customers are single purchase. As you can see, one most of them in top 20, most of them are one. Then there are twos as well. Then there are also a lot of inactivity since along you will see a very few of them are below 100, but most of them are over 100. And then value based risk profile, of course, the monetary value you see only 3,668. That is very, very low. And you'll see only a very one, two, and three. These three outliers have gone into six digits. Otherwise, they are very low. Now we'll move on to basically finding association versus causation. Again, there is no specific code that is being generated here. Our creation of our model is done. We'll understand association versus causation. And you know what a good thing would be, like we talked about logistic regression. We can see, we can go to internet, learn basic understand definition of logistic regression. But I just realized a very good understanding of logistic regression is that all that data that we have fed particularly into this AI, it will provide us a logistic regression definition specific to our data and not a general one. So in the end, we can ask for logistic regression here as well. But the same, we have done it here. So for the low purchase frequency, The flaw is it confuses correlation with causation. And the explanation for this is the low purchase frequency is a symptom or indicator of churn, not the root cause. And then same goes for that your data set only contains purchase dates, counts, and revenue amounts. It does not contain customer feedback. So we basically cannot relate our data into what our customer currently, sorry, not customer, our database. If you go into our database right now, our database is purely mathematical. I'm sorry about that. So our database is purely mathematical. We cannot basically judge or guess whether our product is good or not. We know when product was sold, profit was made, when it was sold, how it was sold, but nothing about customer feedback. So there is no relation between how good or how bad our product is. And our model proves why customers churn. Machine learning models are designed to answer who is likely to churn based on historical patterns and why they are churning. So proving why something happens requires control experiments like A/B testing and direct qualitative research. So basically, not that our model cannot predict why customers churn, but our data limits it and how we have basically made our data. So let's say if we had a much vaster, much bigger database that had customer feedback and that had various other elements of seasons, various other elements of time, various other elements of product categories, product types, liking, dislikings, then we will add those elements as features. Right now, the features that we used were recency, frequency, monetary value. But we can also add features of customer feedback. We can also add features, and we can basically there is no limit to it. But more complex it is, you need more and more testing, you need more and more training, and based on that, you can build your own prediction model. All right. So now what has basically happened? The prediction model that we have basically developed right now, we can bring in any data, any new data, this basically this kind of data from anywhere, and it will predict. I hope you remember with 70% accuracy, it will predict what accuracy, how many customers will churn or not, with a 60%, sorry, 84% recall value, and then 60 close to 65% precision. So in this model of ours, now we can bring any data in the world and we can say with out of every 100 data points, every 100 customers that we feed into it, we can say for 71, it will predict with accuracy. And those answers will be correct. All right. So we have our churn predictions. Now we'll basically design it, our prediction into business actions. So now we are kind of in the end building a report, and that report will basically tell us not basic if you are the directly the business owner, it will tell you what to do, or else it will tell this is the kind of report that you will share with the business owner, and the business owner will tell you what to do, and or maybe either the business owner will tell you or make a decision for themselves how in which direction their business will be. And based on that, if you look at the prompt, so I have customer churn prediction model, high stress customer show patterns. Based on these model outputs, suggest 5 practical business actions. So we are suggesting, and those 5 are: launch automated re-engagement email triggers for first-time buyers, target inactive account with win-back discounts or free shipping offers, implement a tiered customer loyalty or rewards program, introduce personalized product recommendation based on past order history, deploy win-back surveys to high-risk inactive customers. And these are the 5 business actions. Now, kind of, if you, let's say this entire scenario is correct, you'll copy this entire thing, paste it in a well-made document, let's say a document like this, paste it, format it, organize it, and then share it with the business owner. That eventually the business action is what business owner is looking for. And a real business owner really does not care what the data contains, what prediction model you used, how what kind of programming language you used or how you did it. In the end, the business owner wants what actions needs to be taken. And we have finally come up with our 5 business actions based on the analysis that we have done today. And what those what that will do is basically tell us how do we get less and less customers of ours to not to churn. So we want to retain maximum customers and we want less number of customers to churn. So now from this from what we are doing are if a new company that can contact 500 customers, so what kind of retention we are basically designing a business campaign for them based on our production model, and this from will return what the basically retention campaign will look like, and then we can create our final. So this is manual work. So I would suggest, if you, I'm sure you all have downloaded the workbook today. So if you are working alongside with me, great job. We have completed everything. We have made a prediction model. We have made our business decisions. We have even made a retention campaign for our business owners. All right. Now, final checklist. If you have missed anything here, you can mark them done. If you have not done anything, then this should be your final output. We have customer database, yes. RFM features, yes. Churn target, yes. Prediction model, yes. Model evaluation, churn probability, customer level, and business action. We have all of them. And our key question that we had in the beginning of our session, that has now been answered. What might happen next and which customer may be at risk. All right. So I hope you learned today. And we have come with this, we have come to the end of the third masterclass. And we have successfully developed our customer churn prediction model. So thank you very much, everyone. I really hope you enjoyed the session today. And I also hope that you learned something today. So I'll hand over this meeting now back to Tanmita, and she will take you through the processes of the internship, if there are any, and mainly marking your attendance for the session today. So thank you everyone very much. Back to Tanmita.
Hi, Karthik. Thank you so much for this wonderful session that we were able to complete as a part of our project-based learning. And I hope that all of you had a very fruitful learning today in understanding the processes that were shared. And as we come to the end of our masterclass series, up next we have our project discussion that's going to be happening for all of you on the 7th of September, which is a Monday. So that time we will be using to discuss the project that you will be working on and your doubts and clarifications and all of that. So I repeat, students, that's happening on the 7th of September. So that's when we'll be meeting next in continuation to this particular program. And I hope your sessions went very well. The past 3 sessions that you were a part of has been a really insightful learning for you. Maybe picking up new skills, maybe understanding new techniques, understanding new tips and tricks to work through data, right? So glad to know that you had a good journey going forward. I can see one person put nice. I can see yes and thank you and all of that coming up on the chat box. So glad to know that you had a good learning journey going forward. So on that note, I'm just posting the attendance form link on your chat box so that you can all fill up your attendance, right? Just closing the chat box for a minute so that the form doesn't get lost between your messages. Yeah, I have shared the attendance form with you on the chat box. Right? Kindly use this time to fill up your attendance. Your attendance form will also be reaching you in your respective communication channels as well. And take another 2 minutes to fill up your attendance form so that for your particular session it's marked. Right? I can see that some of you have questions and all of that that's happening, and you would have doubts when you start working on your project. So that will definitely be cleared for you in on September 7th during your project submission and discussion and all of that. Right? So on that note, thank you students. Thank you all for this beautiful journey, and I will see you all on September 7th. All right. Thank you. If you fill the attendance, you may leave the session and we'll be closing. Yeah.